Now let's put everything together on a problem like this. I've got this polynomial. I want to write it as a product of linear and irreducible quadratic factors. As a product of linear factors, and list all the zeros of k to x. Well, I know at most there's going to be 5. I know they're going to be factors of 24. If I count the positive sign changes, there's only one sign change, so I have to look for one root. And then I'm going to graph this so I can kind of see where I'm looking at. I can see that my roots aren't going to be anything beyond 4. Okay, 4 looks like a positive root I'm going to have. And it also looks like I got -2 and I got -3 as my rational roots. So now let's use those to find the ones that aren't listed. So let's start with 4. So then I'm going to go 4. I got 1x to the 5th, 1x to the 4th, -13x cubed, -23x squared, -14x, and -24. And I think I should get one of my roots should be 4. I'm hoping this is 0 at the end. So I bring down the 1. 1 times 4 is 4. 1 plus 4 is 5. 5 times 4 is 20. 20 minus 13 will be 7. Times 24 is 28, which will give me 5. 5 times 4 is 20. 20 minus 14 is positive 6, not negative 6. 6 times 4 is 24. There we go. One of my roots is 0, or one of my roots is 4. Now let's check the other ones here. Let's check -2. So I've got -2. And we'll check that one. So I bring down the 1. 1 times -2 is -2, which gives me 3. 3 times -2 is -6, which gives me 1. 1 times -2 is -2, which gives me 3. 3 times -2 is -6, which gives me 0 again. Okay, looking good so far. Now let's check my third rational. Let's check -3. So I get -3. So then I'm going to go bring down the 1. 1 times -3 is -3, which gives me 0, 0, 1, -3, 0. Now I can write this as a product of linear and irreducible quadratic factors. So in other words, I'm going to say x minus 4 is one root, times x plus 2 is my second root, times x plus 3 is my third root. Now remember, we started here with to the 5th power. So this is to the 4th, to the 3rd, squared. So in other words, I've got an irreducible quadratic here at the end, x squared minus, or x squared plus 1 equals 0. That's the first part. I wrote it as a product of linear and irreducible quadratic factors. Now I want to actually factor that x squared plus 1. Well, notice if I solve x squared plus 1 equals 0, we'll do that over here. I'll get x squared equals -1. So x is positive or negative I, because I take the square root of both sides. So then my second answer, as a product of linear factors, I'm going to start the same way. It will be x minus 4 times x plus 2 times x plus 3. Then I'll say x minus I and x minus a negative I, or x plus I. So those are all your linear factors. And then list all the zeros. So my zeros are going to be 4, -2, -3, and plus or minus I. So make sure you answer the question that's being asked on that. And there we have it.